This is the first video for sample exam number 1 for Math 107. There will be problems on symmetry. In this case, it's symmetry of a crystal, and you'll be presented with a picture of the crystal, and you're to draw on it the axes of symmetry. An axis of symmetry is one that if you folded the picture about that axis, both sides would fall right on top of each other. They would be the same. So we have here a snowflake or crystal that has six-fold symmetry. So you can see there's symmetry through the points. You just draw lines on here to find the six-fold. Obviously, if you this line, it would be symmetric about that. Same on both sides. And then you have another one. Well, I missed the point, but okay. And then here's another one through this point. So it's symmetric about all those three lines. Sorry, I didn't draw them so good. Okay, now how about the flat faces? If you drew through that flat face, let me get different colors so you can see that a little bit. Okay, here's that flat face. You see it's symmetric about that as well as the points. And of course there are two more flat faces here, and that gives you the symmetry for this crystal. And the whole idea here is to refresh in your mind what the idea of symmetry is. Nothing is just symmetric. It's symmetric about something. And it's symmetric, since we're dealing with a plane here, we're symmetric about lines in the plane. So if we draw a straight line and both sides of the figure or the graph are the same, it is symmetric about that line. Now we look at symmetry in terms of the algebra of the function. And if a function is symmetric, right, about the y-axis, that is the vertical axis, it is called an even function. All right? And if it's symmetric, what it says about the origin, we say about the origin, then it is an odd function. Right? Algebraically, what this means is that if you substitute minus x for x into the original equation, which would be this one right here, and you get back exactly what you had as you started with, then you will have an even function. If you get back the negative of everything you had, that will be odd. If it's some kind of mixture, then it's neither. Okay, so I'm going to start here by looking at 3. It's written there, but I'm just going to show you here since it's a video. So I go back, I put minus x here, and every place there's a negative, there's an x, I stick minus x. Seems like my virtual ink isn't working. There we go. Nothing to do there, and something to do there. Use parentheses. 3, and then I've got minus x squared. Alright, plus 5, no x on that term, and now we have the absolute value of negative x. Once you've done the substitution, work out the algebra. Okay, when I square a negative number, and it's in the parentheses, the negative sign gets squared away. So this is 3x squared. This is that important point that I've belabored before, that if you have minus x squared, that's not the same as the minus x in parentheses. All right, because this term, the last, is really x squared. Right. So I want to continue this one up here. So the next term with the plus 5 is 5. And now if you take the absolute value, maybe we should review what absolute value is. Absolute value gives you your distance to the origin. All right, that's what is said. What it does in practice is it just strips off any negative sign. All right, so that negative x is the same as positive x. It's exactly the same, so I can write that as the absolute value of x. And that is exactly what I started with. Therefore, it is an even function. I'm going to go back and I'm going to do the same thing for this. So I start with that function, but I'm going to put a negative x in everywhere there's an x. And remembering to use parentheses. This is negative x raised to the 5th power plus 3 times negative x cubed. Right. If you have negative x, let's just do the cubed, raised to the 3rd power, it's in parentheses. This means negative x times negative x times negative x. Well, these two negative signs go away, but this one remains. The answer is negative x cubed. All right? That holds true as long as that exponent is odd. If that's odd, you'll end up with a negative sign left over. So the answer here becomes negative x to the fifth plus, and this would be 3 times negative x squared, so I actually should have put, let me fix that. So this is negative x cubed times 3, so it's negative 3x cubed, and you see that's exactly what I had in the first part. I can factor out that negative sign, x to the fifth plus 3x cubed, and you see I have negative of what I started with. Therefore, this is an odd function. So the trick here on algebraically to show if it's even or odd is put in negative x everywhere there's an x. The important thing that I want you to do is know how to do that substitution, then carry this out correctly. Demonstrate an understanding that if you have a negative number in parentheses, then that whole term is squared or cubed or raised to the fifth power. This problem has to do with the domain of a function. The domain of the function, let's say a function of x, are all the acceptable values of x. The little thought process we go through is first we say it is all the real numbers. And then we throw out any possible division by 0. And then we throw out trying to take the square root or even root of a negative number. There's no square roots or, fourth or powers or anything like that in there. The only thing we have to worry about here is the potential dividing by 0, and that would occur if this denominator goes to 0. So we have to find the values of x that would make this denominator 0. The way to do that is to factor. All right? Basically what we're saying is we want 25 minus x squared to equal, interesting, 0. Well, I kind of factored it backwards here, but I think you can figure that out. How do you factor this? This is one of those special forms where it's the difference of two squares. Right? And it works like this. So it's 5 minus x times 5 plus x, and if you FOIL that out, you will find that you end up with 25 minus x squared equals 0. And you want to find out where that would happen. And of course, it's going to happen when x is 5, or when x is equal to negative 5. All right, and that's written right here. Those are not in the domain. They have to be thrown out of the domain. So there's several ways to express that. One way is with what's called set builder notation, and you can write it like this. It'd be the set of all x's. You have to use the curly brackets. I didn't do a good job. Set of all x's, and we're assuming reals right now, or you could say that's in the reals. It's a real number. The vertical line means such that. Right. X is not equal to, my virtual ink seems to be running out, 5 or negative 5. Now that's set builder notation, and it's perfectly fine. All right. This means all the real numbers except x being 5 or negative 5, because those are the ones we threw out of the domain. There's another way to write it, and it's shown here. Where's the highlighter? Okay. It's shown right here. And this is writing it in terms of the interval. So if you want all the real numbers, you would be going from minus infinity to infinity. But here we want to throw 5 out. So we come up to negative 5. We want to throw negative 5 and 5 out. And we put in parentheses. Parentheses means don't include the endpoint. Right? Don't include the endpoint of this interval from minus infinity. Come up to minus 5, but don't include it. Then we have a u, meaning set union, and we pick it up at minus 5 and go to 5. Again, the parentheses means don't include the 5 or the negative 5. Jump over 5 and go on all the way to infinity. So there's several things to review here, and I'm going to go over those now. Okay, I gave myself some room here and also erased my shame of factoring with the wrong sign, which really wasn't significant, but at any rate, here we go. Here are things I want you to review on this. Know what a domain is. A domain is the acceptable values of x. Acceptable values of the independent variable x. So things you can't do is you can't divide by 0, and you can't take the square root of negative numbers, at least if you're dealing with real numbers, which is what we're dealing with in this chapter. Right? So that's that's the first one. The second is, how do you solve an equation like this? 25 minus x squared equals 0. Well, remember that this is not linear. A nonlinear equation, you throw everything on one side. Well, these quadratics anyway, throw everything on one side and make it equal to 0. Then you're going to factor it. So in this case, I factor it. 5 minus x, 5 plus x. All right? And set each factor to 0. So first I start with this one, and I set it equal to 0. 5 minus x equals 0. Obviously, if x equals 5, that's going to happen. So there's my first answer. Then go back here, look at the other factor, and set it equal to 0. 5 plus x equals 0. X equal minus 5 is my second answer. Why do I have two answers? I expect two answers because it's squared. So you see there's a lot wrapped up in this problem. This idea of factoring something, and if it's equal to 0, you have a solution for each factor being equal to 0. This is a big concept. You don't just see it here in algebra. You'll see it in trig. You see it in calculus. You see it all throughout mathematics. If you have a problem with that, contact me or get with a tutor and figure that out. And the third thing here to think about is how to express results in some kind of mathematical language. Now, scribbling 5 minus 5 somewhere on the page and maybe even kind of circling it, that isn't right. That's like illiterate. Okay, so you can do better than that. And here, if you want to exclude 5 and minus 5 from the real number line, here's how you do it. Start at negative infinity, the lowest number, get up to the minus 5. Now by putting this parentheses, it means don't include the 5. If I go minus infinity, to negative 5, and I put a square bracket, that means include the 5. We want to exclude it. So we get right up to it, jump over it, start up again, and head to the next number, which happens to be 5. I don't want to include it. Put the parentheses, jump over it, and now there's nothing more to exclude, so I go all the way to infinity. So there's two times you use the parentheses. One is if you don't want to include the endpoint, which is right here, of the interval, and the other is by plus or minus infinity. You can't include them because they don't really exist. So you use the parentheses there. Now this should be fairly simple. This is just an exercise in function notation. Remember that if an equation is a function, then instead of having y equals something, you give it another name, and that name is f or g, a letter, and in parentheses you put the independent variable. In this case it's x. So f is another name for y. But when you put a value in here instead of x, that means every place there's an x, you have to put a 12. So this would be 12 squared plus 3 times 12 minus 6, and you get whatever answer you get. On a test, you will not use a calculator. It is not important that you come up with just exactly the right number to 3 decimal points. I could care less about that. I want to see this work. I want to see you putting 12s where they belong. I want to see you making a stab at working it out. This, I really don't care about. I want to see you work the problem out. Because how many times in your life are you going to be confronted with find f of 12 if f is x squared plus 3x minus 6? Probably only once. But you need to know how to do it.